And I really wish I had taken a year. And
Taken what?
I've taken a year in between.
Oh, yeah. Yeah.
I probably would have gotten a lot more out of the experience had I had a little bit more perspective.
Totally. And in general, I really advocate for the community college thing to start, because it gets you, you don't lose any time, but you do sort of gain that time for perspective, you know, like you can chunk away at your gen eds and like all the classes you'll need no matter what you're taking at like a reasonable cost. And I think it's like, I understand why people don't want to when you're young and you want to go away the way all your friends are going away, because like same. But it actually turned out to be like the best avenue.
Yeah, it's not something my university wants me to say, but I agree. Going for 2 years at a community college and then transferring, I mean, you end up with the same degree at the end. You pay half as much for it. And yeah, and you get a good idea of what you want to do before you kind of commit.
Well, and for anyone who might need, just is not going to thrive in a 400-person chemistry class, you're going to get a lot more out of a small or class size than a 400-person lecture hall.
Yeah.
Yeah, and those like professors tend to be like, the mentor mentality seems to be like built into like community college professors. Like it's almost like they're doing it because they want to, right? Like, and that I think helped me get a lot of like questions about what I should be doing sorted out with that, like that sort of guidance.
No, I think you're right. I think there's definitely a focus on teaching in a way that there might not be at a big university, where the demands on, you know, R1 research professors are insane, and I am amazed by everyone that I meet, like Kevin, Meredith, that can do those things, just get pulled in 50 different directions at once and pull it off.
It never ends. I have to do all my own accounting, all my own science. I run a lab. I run an external facility, so I run clientele for people around the world.
Wow.
I have to do my research. I have 4 graduate students. I got like 4 undergrad students, and then I have to teach classes and develop the classes.
Oh my God.
Yeah, it's exhausting. I've lost a lot of hair in the last 2 years. My health has gone down. But it's fun. Eventually it'll settle out and I'll have the classes made at least.
Yeah.
I'm developing marine geology. It's going to be taught for the first time at UNLV. So that's going to happen in the fall. So it should be fun. I'm going to try to use a lot of dive footage.
Awesome.
Yeah.
So offered online, because I'd take it.
No, it's in person.
Roger.
You're welcome to come and visit.
Set up a webcam for me, Kevin. I just want to sit in. I'll audit it.
Yeah.
Yeah, so Meredith, you work for NOAA, National Oceanic and Atmospheric Administration.
Yep.
And what's sort of a yearly schedule look like as someone who's a research professional for a major U.S. agency?
So it varies a little depending on what projects I'm working on. So my work is largely project driven. So for the last few years, majority of my work has been West Coast focused, because I am also the research coordinator for one of the 2 research coordinators for the West Coast Deep Sea Coral Initiative, where we've been getting 3 years worth of funding to do ROV work on the U.S. West Coast. Some of which was done in partnership with Nautilus in 2020, to do surveys out there. And then because I'm in fisheries, I also end up working on some fisheries projects looking at the interactions of particularly things like rockfish populations and untrawlable habitats with deep sea coral. So the kind of research year is, this is the big field time of year. I have a pretty busy field season this year. This is the second cruise of 3 that I'll be involved with. The last one will be in September, and it's doing coral and sponge surveys off California and Oregon. And then during the kind of off-season months is a lot of work in the lab. So starting in about September, we'll have, or I'll start in August, but August and September, we'll have this mad rush for the eDNA lab where 2 or 3 different environmental DNA projects will all be signing up for time to get our samples extracted. And then it's just data processing and data analysis that kind of go on through the rest of the year. That's when I run a lot of my like barcoding samples. I'm also right now, I'm doing a bunch of the genetics projects for the Alaska Deep Sea Coral Initiative. So in addition to the samples from this expedition, in August I'll be processing eDNA samples from the Aleutian Islands. So it's just a lot of projects, a lot of my time, at least 1 day a week, is spent just like making sure I know which projects I'm working on.
I'm just gonna go back a little bit. Sorry.
Sounds cool.
So also being pulled in lots of directions.
Yeah, I mean, it's all largely research driven, but the thing with working for a federal agency is all of our research has to have a federal management perspective. So we're answering questions that are going to lead to management decisions.
Whereas I can just float around and grab seamounts. Focus on deep earth.
And while I don't teach outside of, I do give the occasional volunteer lecture when I get asked to. I enjoy doing that. I do take student interns from time to time. So probably next season we'll be taking a hauling scholar. So that's a NOAA scholarship program for undergraduates. They get to come work in a lab for 9 weeks.
Don't forget to apply, folks at home.
Yeah, I was going to ask you if you do all that work like physically yourself, or are there technicians that help out?
I do get some help from some of our technicians, but they work mainly on a lot of the fisheries projects. So I do a lot of it myself, but shout out to Abby, who does work on some of the coral stuff with me, helps me get all my sequences processed. It's always greatly appreciated. We basically in the, so I'm in the genetics group, and I think we have 15 people, and we have 1 technician who kind of works with everyone.
Oh, wow. They must have quite the varied skill set.
Yeah, she's fantastic.
Here's another question in the chat. How much voltage do the ROVs run on?
Yeah, that's correct. 480 is correct.
Was that an answer to the question? Because if so, it wasn't on SPO, sorry.
Yeah, a 480 is the voltage that the vehicles run on.
That's like double my stove.
Yeah.
That's a lot of power.
Okay.
It's a lot of voltage.
You're right.
Not necessarily a lot of power.
Not necessarily a lot of power.
So, okay. I have to pick up the slack for our electrical engineering student over here who didn't complain about that. So
I'm just gonna mute you.
I've been grilled about that enough times, so I thought I'd just pass it along. It's a cycle, you know? So actually on the power thing, do we know how much power Hercules uses like on average and how much it can use? Do we not have an ammeter on the
I was going to say volts times amps equals watts.
30, what is it? 30, which one is it? All right, wait, so 40, hang on, I'm gonna do some math now. So it's all like 2 kilowatts. And that's a pretty normal value. I mean, does the hydraulic pump just like go all the time, or does it change? Okay. So that's like the equivalent of like 2.5 horsepower. Well, kinda. It's a big, heavy vehicle.
Fun story. Do you know how James Watt figured out how much horsepower was?
By having a horse drag ROVs
Yeah,
in the water column?
it was basically, they were using it basically how much he measured it by how much water, or how much weight basically a horse could lift up a mining shaft over the course of a day.
Yeah.
Right?
Exactly, right.
Yeah.
So, you know, like spinning around on one of
Right,
caps.
which makes a lot of sense because that's an easy way to measure, it's a very easy way to measure power. Well, yeah. Yeah, how high you pull up yeah. You can measure potential energy very easily that way, and then you can measure that over time. So, easy calculation. And I guess he did it, like that was initially for steam engines, right? To sort of give an idea to the general public about how much power a steam engine could put out and how much work the steam engine could do.
Right,
Yes.
right.
Yeah.
Yeah, it's kind of insane that that unit somehow survived the test of time.
Yeah, exactly. Right. We didn't go to joules.
Well, it would be, the analogous one is watts,
Watts, right?
right?
Yeah.
Joules is energy.
Right. So, okay, right. And so across the distance. Yeah.
Yeah. I mean, we do use watts for a lot of things, but even, and now that electric cars and things are starting to come up, that's starting to be a more common unit to look at. I think there's sort of a incentive now to not use the same unit, because I mean, you can, but the horsepower of electric cars is not really directly analogous to what you would get out of an internal combustion engine. So it doesn't sound super impressive always. So we're just going to like switch units to the one that we already use for electric stuff anyway. So it works out.
That, I mean, electric cars typically have, you know, more towing capacity, right?
They have a lot of, their main thing is they have a flat torque curve. So they can produce the same amount of torque at any engine RPM, basically.
Okay.
Which internal combustion engines cannot. No, I mean, they're very competitive in terms of, electric engines are very competitive, but they tend to have, you can do more with a lower horsepower rating with an electric engine than you can with an internal combustion engine. So it's not that they're like inferior, it's just that they don't, the numbers don't crank as high because they don't need to.
Just watched a drag race start between a supercar that's electric versus a supercar that is not. They often are faster off the start line because they have that flat torque curve.
Yeah. Yeah.
I've never driven one. I wonder what that acceleration must feel like.
Yeah. One of my lab mates just bought an electric car, and now he just he can't wait to get stopped at red lights. That's his favorite thing now, especially if he stopped at a red light next to a sports car. 'Cause he's got this thing that looks like I don't know, it looks like a crossover boring SUV and whatever, and then he just tears off in front of the BMW or whatever is next to him. Although that thing is heavy.
Yeah.
I have a Tundra for towing boats and stuff around, and his little crossover SUV weighs as much as the truck. It's crazy.
Dense.
Yeah. The battery thing is...
But it drives like a golf cart.
But it drives like a golf cart, yeah. Well, yeah, and then that's that, yeah.
So interesting, even though electric vehicles don't have sort of a big block engine
Yeah.
that adds a lot of weight, they still could weigh as much as
Yeah, well,
the
I mean,
batteries, yeah.
it weighs much more than a comparable sized gasoline car.
Mm-hmm.
I mean, twice as much.
Okay.
Two, maybe 3 times as much. The batteries are still a serious limiting factor, at least in terms of weight. So weight doesn't matter as much in cars as it does on some things, but when you start getting into boats and airplanes and stuff, it's we're still a long way off from that.
An electric boat seems like it would be a great thing just because it would be ballast, right?
Yes, but you have to... So in a car, you can kind of gain a lot by aerodynamics and just kind of coasting. Mm-hmm. In a boat, it's a constant force at pretty high, pretty constant force for very long periods of time, right? So you can with the weight restriction, planing boats are out of the question. At least planing boats with any kind of endurance. Displacement boats you can do, but displacement boats are slow and take a long time to get places and need. So I mean, there's some stuff starting to come out. The thing that I've seen that I like is the hybrid electric sailboats. Have you seen these?
No.
So they have. This is the point. I think this is the place where it really makes a lot of sense. So depending on how you're using it, you can get a electric thruster, batteries and sails, or electric thrusters, batteries, sails, and a diesel generator. If you're just if you're just coming in and out of the harbor and doing day stuff and whatever, they tend to not have the generator. But they can actually recharge under sail. You can backdrive their thruster and use that to charge the boat. And it actually gives you a pretty nice off-grid battery to live off of.
Yeah.
You can run your appliances in the boat and run the battery and run lights and whatever else you want.
Right.
And you have more battery than you ever would in a conventional setup. And if you have the generator, you can sort of go farther out and do off-grid sort of cruising in places where you don't necessarily have access to shore power and stuff to charge up, or you're not going to be able to sail for long enough periods of time to charge it up. I mean, you have to it takes days to charge the battery off of a 50 amp shore power thing.
Okay.
So you need, if you're going to be cruising and doing hundreds of miles every day, you still need the generator, or to be sailing.
Relevant to those of us who live on islands in Washington State, the whole ferry fleet is going to be converted to hybrid electric by 2024.
Mm-hmm. Most new research ships are too, because they do it mostly for control reasons. You have a lot more fine-grained control over an electric motor than you do over a directly geared transmission sort of thing. Yeah, so for something like a ferry, it makes an awful lot of sense. Something that spends a lot of time docking and maneuvering close to shore.
So, are there small electric planes yet?
Yes, there are. There's a company called Pipistrel that's a composite airplane company, and they did a lot of stuff with like they sort of started out with like high efficiency gasoline engines, and they did like motor gliders and that sort of thing, and they sort of have morphed into the first commercially available electric plane. They work well. They have comparable performance. They're a little heavier, but they only have an hour and 15 minutes of flight time.
Oh, wow, okay.
And in the US, you're required to have a half hour of reserve fuel capacity for any flight. So now you have a half hour or 45 minutes of usable flight time, which is just like
Commuting.
not,
Yeah,
I
maybe.
mean, it's basically not viable
Right.
for anything other than like a flight school or training, which is where they're starting to show up. But I mean, you got to start somewhere. I mean, I don't mean to be too negative on it, but like, and they have proven to be effective, and people are starting to use them. Like I said, in particular, the flight schools like it because they're very low maintenance and cheap to operate and that sort of thing. Yeah. Yep, no problem. There are some, not commercially available, but there have been some solar-powered airplanes that have done like round-the-world flights and stuff nonstop and that sort of thing. But those are like ultra-specialized, right? They're basically super high-performance sailplanes that have a electric engine to sort of maintain flight and have just enough battery to fly through the night. So, and I think that they actually store a lot of energy just in altitude, not in it's more efficient to store your energy as altitude than it is to store it in batteries if you have a sailplane. So you just like spend the day climbing on natural air currents and on your solar power, and get to your maximum altitude, and you like just slowly glide down through the night and use your electric motor sparingly to maintain until the sun comes up again and you have solar again.
Oh, wow. Okay, that's a... Yeah, there was a... What, was in the maybe late 80s or 90s, there was a plane that...
That was Voyager. That was not solar power.
That was not solar powered, okay.
The other cool non-gasoline airplanes are some of the regular sailplanes. Some of these things do 120 knots for 1,000 miles up and down the mountain ranges. A couple of years ago, somebody built one to climb to 75,000 feet. We're talking like, that's like U2 altitudes almost, right? Like it was nuts.
So it's just, I mean, we call
Totally
it
unpowered.
a glider, right?
Totally unpowered, yeah.
Okay.
What it does is there's big...
Rise of thermals, right?
Well, the thermals don't get you that high.
Oh,
What
okay.
they use is it's called wave soaring. So when the wind, like on continental scales, when the wind blows over a mountain range, it like creates it lifts, and then you get like an oscillating wave downwind of the mountain range. So if you ever look behind a mountain, you can see what's called a lenticular cloud,
Yep.
right? And that's why, because that's like warm air being pulled up under the wave and like rolled around in the rotor underneath. But that's the only way that they can get up that high, because that effect goes way up into the upper atmosphere.
So they're like surfing the airwaves.
Yeah, exactly. And I think this plane was doing something like 200 knots or something. You just have to go that fast to stay aloft that high.
Huh.
So how is the advances in battery technology being applied to ROVs or AUVs?
It's not really being applied. Well, it is being applied to ROVs, because when you apply it to ROVs, it means that you can have a much smaller, more portable tether. So you can, so like Nereid under ice NUI is one that runs on just a tiny fiber optic strand, or can. They don't always, but they can run on just a tiny fiber optic strand. And the idea is they can go under ice sheets that way because you don't have to dangle this big, heavy 6/8 cable, right?
Okay.
So, but that relies on battery technology. But I think NUI actually uses pretty conventional, like lead acid batteries.
Probably.
Some of the modern, more smaller AUVs are starting to use lithium and stuff. Honestly,
the gliders do.
Yeah, it's not as important in the subsea world, though, to be honest. Like, the capacity is nice, but the weight doesn't matter so much because subsea vehicles are heavy anyhow.
Yeah, there's some of the new HUI AUVs I think are lithium, and the biggest thing is just trying to get their battery life long enough.
Right. Yeah, and they still aren't using them in human-operated vehicles because of the fire hazard.
Yeah, they use the, what did you call it?
Lithium?
Yeah,
Or
lead acid.
yeah.
Yeah, lead acid.
Yeah.
Yeah, when lithium batteries go off, it's impressive.
Yeah, they don't go out. You just gotta keep the fire burning slow enough so it doesn't destroy too much around it.
I used to build AUVs as one of my jobs. It was like I was in production side of like ocean technology, working for a company like on an assembly line doing like the forward buoyancy pump section of the gliders. So they're pretty cool because they just dive and climb through the water column by expanding and retracting its a bladder in the nose and then shifting the battery weight just enough to change its pitch.
Oh, really?
Yeah, yeah.
Oh, so this is one of those sort of torpedo-looking things. With
Those are, yeah,
okay.
those are the Slocum gliders from Teledyne.
Okay.
It was just like really comparable to like the Hydroid AUVs that HUI is like associated with.
Okay.
Those are cool.
Yeah, how many of those get built, or is that a trade secret? I mean,
It was
are you building
cool.
hundreds, or are you
It was
building
so
one
cool
at a time?
I didn't really understand what my what I'd be building really, because they don't tell you till you take the job. But it's
Okay.
like it's all the parts from like wires like that don't have any connectors on it, and just tubes that aren't plumbing yet, you know, and like you do all of it. So you learn a lot about like what everything is called, right? Because everything has a part number. And so you're like, oh, like, you know, it's just like, it taught me so much as being like a good way to build some skills for this industry. So you're soldering everything, you're connectorizing everything, you're pressure testing, oil filling, and like sort of burping the air out of the pumps. It taught me a lot. It was very cool. It's very involved. Building valve assemblies, getting O-rings perfectly seated in very precarious positions, and working with like machining departments to modify sometimes when things don't come as they are meant to fit together, and getting them maybe shaved down, you know, moderately just to get everything to sit correctly. And I used to like treat it like they were like having kids.
Mm-hmm.
Like I've got like, if I finished 2 in a day, I'd be like, I made twins. Like, sometimes they would not do that well on the pressure test stand. They just need more maintenance, you know? And they'd be like, I don't know, I'd treat them like kids that didn't want to go off to college yet. Like they're just like wanting to stay in the house. Like you gotta go meet your full potential. But that was fun. And then going out and being a Marine tech on the Endeavor and like having gliders be there and like, what's the serial number? Is that one of mine? And how's it behaving, you know?
Yeah, it comes full circle.
Yeah.
Sonia, any last internet questions before we do the recovery?
Yeah, I'm seeing. Okay, here's an ROV question. So do Argus and Hercules have some sort of fail-safe failure mode if the tether were somehow cut or broken? Or would the ROV just be dead in the water?
If the tether between Atalanta and Hercules was severed, we would just winch up Atalanta on the 6-8 cable that's connected to the ship, and Hercules is slightly positively buoyant, so it would just float to the surface, and we'd probably deploy a small boat to clip into it and then use the crane to get it back on board.
It's a cool looking jellyfish in the can.
We're finally getting into some like gelatinous plankton. I've seen some pelagic tunicates in the background and a couple pteropods.
I love jellyfish. They're so cool.
Yeah.
I'm trying to remember when this was, but at some point I was given a like behind the scenes tour of Monterey Bay Aquarium, and they showed me how they basically grow their own jellies. I thought that was so cool. I was like, could I grow my own jellies? Like, could have them in my room or something? But it's a lot of like physics with the ocean currents and stuff. So yeah, that was just so cool.
Jelly farms will have to wait.
They put a lot of work into those circular tanks so that there's no edges and they can recirculate the water to keep them all suspended.
Did you turn the DBL off? Okay. Oh.
It's crazy to think that jellyfish and coral are the same phylum. They seem so far apart from each other at this point.
Yeah. I mean, that's what it looks like, so.
There are some ways you can tell. There are some jellyfish, like the moon jelly, that actually have a benthic phase, where they grow on the substrate on the seafloor in this little stack of jellyfish discs, and then each of those pops off and becomes a new free-floating jellyfish.
Sounds crazy.
Looks like a stack of pancakes.
Yep.
Stingy pancakes.
What is that?
Some kind of ribbon-like animal.
Hmm.
Here's another question in the chat. What are you hoping to see most on the next dive?
Good rocks, cool critters.
We'd like to see a lot more corals and sponges. We're on a lookout for a couple of particular species of coral that are of interest for some additional taxonomic work, particularly from the Chrysogorgidae and the primnoids.
I want to see a sea spider.
I'll take anything that would become a highlight.
Yeah, I'd like to see an octopus. I haven't seen any time I've been on a dive. I don't think I've ever seen an octopus.
We're going to get you one.
Yeah.
You need to come work on Cascadia margin.
Yeah.
It's all octopus all the time out there.
I know, I love it. I watch them. But yeah, not as popular on seamounts.
Be nice to see some lantern fish, like we were talking about earlier, the myctophids, as we descend through the water. I guess that's maybe more of a nighttime thing.
I'd go for any non-eel deep sea fish, since we are seeing a lot of the cusk eels and cutthroat eels.
How about you, Chanel?
I'd probably have to agree with octopus. That'd be pretty cool to see.
I would like to see an octopus that's in motion. Because we had an octopus on the last expedition. It's just kind of sitting there. His legs were all like sort of curled up underneath him. It's like, well, you are an octopus, but
do something.
I'd like to see more of you.
It's kind of like when you go to the aquarium.
The Seattle Aquarium every year for Valentine's Day likes to open the gate between their male and female octopus. And sometimes they don't because they've had a couple years where one of the other is bigger and tries to eat the other one. My favorite thing about octopus in aquariums is the lengths to which the aquarists have to go to keep the octopus in their allotted tanks. So like at the Seattle Aquarium, the octopus tank is actually out in like the viewing area, completely separated from all of the other tanks, because octopus like to go walking at night and will often figure out what tank has things like delicious crabs and other things and move from tank to tank, given half a chance.
You remember how I said that there was octopus that accidentally ended up in a bio box? Like he had to have either been like gotten in himself or maybe was on the backside of a rock that we didn't catch, something to that effect. But imagine we put him back in the water. I would imagine it'd be like getting on the wrong bus for him. He was like, oh, I really made a mess of this. I've got a long transit home.
Getting on the wrong airplane.
Yeah, totally.
Now the other question is, that could either be a testament to how well Herc's bio boxes seal up, because octopus are notorious escape artists, or that octopus had just decided that the bio box was a clearly wonderful, cozy hiding place.
Yeah. Probably I think the second one. Is that the DVO? Raj.
What's the coolest aquarium you've been to?
I mean, the National Aquarium in Baltimore.
Oh, sorry.
The Georgia Aquarium in Atlanta is pretty amazing. Whale sharks and stuff, I mean.
Monterey Bay is the best that I've been to. It's classic.
Yeah, Monterey Bay is up there in my stack. I haven't had a chance to go to the Georgia Aquarium yet, but it's on my list.
Probably the Shed Aquarium in Chicago for me.
I've never been to that one. That's that and the Field Museum are
Field Museum is fantastic.
Oh my
places
gosh,
I want to check out.
Field Museum is amazing.
You could spend days at the Field Museum and still not see everything.
It's my kind of museum.
We're seeing just how clear the water is. We're at 87 meters and you can definitely see daylight.
I'm all stop on the winch. 50 meters.
Deck, van. We're all stop 50.
Roger, all stop 50. Bridge deck, like to recover vehicle. Golden Cups. Roger, coming up.
Roger, coming up.
Oh, sorry.
Oh, that's a fish.
Bridge is ready for recovering.
Sorry. Trying to iris down.
Deck,
No
say
worries.
again.
Bridge is ready to recover.
Roger.
There we go.
Bridge nav, reduce thrust 25%.
Okay, Roger, reducing. %25 now.
Okay. Hmm? Okay. Are you worried about the res? It hasn't gone over 20, any recovery I've been in the van this trip. Our last one got to about here and then went back down.
Bridge nav, hold position.
You can always drag your camera out.
They,
We have 77, 78 res percent.
yeah, well, it should just be the thrust limit. I don't, like, it's not...
The water.
Power secured.